Hello students, Miss Slyman here, talking to you about how fast the flu is spreading. Really appropriate with how fuzzy my head is. If I make mistakes because my head is fuzzy, please go talk to Miss Patali too. She can help you with this as well. But let's look at this. So we're going to use this to connect to the second derivative test. In the last video, we talked about how we could compare values of the first derivative and look on either side to determine if we have a max and min. So if my first derivative goes from positive to 0 to negative, I have a maximum because my function went from increasing to decreasing. If you think about that as well, though, a function going from increasing to 0 to decreasing is also concave down. So let's look at connecting this idea and other ideas with our second derivative. So here's a spread of the flu. So this is our number of days, and this is in time. The f of t axis is number of people that are infected in Calculosopolis. Here's the function that models it. The population is 1,000 people. So looking at how it changes over the 21-day period, well, if we think about what happens at the start, if I plug in times 0, this value is going to be really, really close to 0. The e to that value is going to be really close to 0. So basically I have 1,000 over 1,000. So we start with one person infected. Well, that one person infects a few other people slowly over the first 4 days, and then suddenly a lot of people get sick because each person is infecting other people and your germs are spreading. But then it slows down at the end because by the end of those 21 or 22 days, everyone in Calculosopolis has been infected and has had the flu. So that's what's happening there. When is the number of infected people growing the fastest? So I want to know where my rate is growing the fastest. So I want to know the max of my f prime of t. So now I'm not looking for a maximum number of people infected. I know that my maximum number of people infected is 1,000. I want to know when is the rate, when is the number of people being infected growing the fastest. So I want my max of f of t. So to find that, well, my max of f of t, my max of f prime of t is happening when the rate of change of f prime of t goes from positive to negative. Well, that means I'm going to look at my second derivative going from positive to negative. So f double prime of t goes from positive to 0 to negative. Well, to find that, I would want to find second derivative values. Thankfully, I don't need to do this by hand. This is certainly a calculator problem with this kind of numbers. So let's come in and find our derivatives. So I'm going to come over and change my graph. And let's clear this out. All right, we are going to have 1,000 divided by 1 plus 999 times, make sure to use your E button, so not ln, just e to the x, and in this case we're going to go negative 0.603 times x. All right, so there is our function. If I go in and change my window, I can make it match. So let's go with 4, and our window settings, we're going to go from 0 to 22 days, and we're going to go from 0 to 1,000 people. All right, so it looks like we wanted it to look. And now I'll come over here and let's use our menu and calculus and find the derivative with respect to x of f1 of x. There's my first derivative, and then I can do that again. So I'm going to go menu, calculus, derivative with respect to x, and this time I'm going to take the previous value. There's my function, and now I can solve this function equal to 0 with respect to x. And here is where my second derivative is equal to 0. Based on my original picture, I know that my first derivative is going to be positive, 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 positive. So first derivative, constantly positive. My second derivative, though, it's positive, but slowing down and then increasing again. So I know at this point, my 11.54 is where the second derivative was 0. So this is the greatest value of my first derivative. So coming back to what we were looking for, we want our second derivative value to be 0, and then hopefully my second derivative is going from positive to negative. So they asked us to fill in these tables, and I'm going to leave this to you because you can do that using your calculator. And then where is f prime of t increasing? Well, let's look at our graph. So I can add in our d. How can I graph this? f1 prime of x. Is that going to work? No. Let's try that again. So d dx of f1 of x. No. Let's see here. Here is my first derivative. We can just copy and paste it. All right. So here is my second derivative graph. Sorry, that's my first derivative graph. I'm going to turn this one off. And I can see that in this first derivative graph, the value of the first derivative is constantly positive, but it has a maximum, and that maximum happens at where my second derivative is equal to 0. But let's think about our slopes here. I have a positive slope, a 0 slope, and a negative slope. So my second derivative goes from positive to 0 to negative. So the values of f prime of t are increasing where the second derivative is positive. So f prime of t increases for f double prime of t being greater than 0. And this connects back to what we said a few days ago looking at our change in value of our stocks. That we said that it was increasing when the first derivative was positive. So now first derivative is increasing when the second derivative is positive. It's decreasing when the second derivative is negative. Getting to my answer in question 4, looking at the graph of f of t, well, in this case, this shape is concave up. So I know that my first derivative is increasing because my second derivative is positive. That happens at concave up. In this area, I have concave down. This is where the second derivative is negative. My first derivative was still positive though. That slope is still positive. It's just becoming less and less positive. In this area, concave up, our second derivative was positive. Our first derivative is also positive, and it's becoming greater and greater. So very flat, and then steeper and steeper and steeper. So first derivative is increasing. In this area, first derivative is decreasing. My function is constantly increasing, but not the first derivative. This is my steepest point. We also call this our point of inflection. Inflection. Where we've gone from concave up to concave down. So, analyzing behavior with a second derivative. Well, we want to analyze more than just the second derivative. We want a function values as well. So, if f prime of a, let's make a chart here. Come on, straighten the line out. There we go. F double prime of a and result. All right, so if f prime of a is equal to 0 and our second derivative is greater than 0, this is greater than 0 for a second derivative is concave up. Our result is we're going to have a minimum. So concave up, points like this. First derivative is 0, means a flat slope, so we have a minimum. If our first derivative is 0, second derivative is negative, well, negative makes me frown, so that's concave down. Concave down has a shape like this. If the first derivative is 0, that's going to be a minimum. Sorry, that's not a minimum, obviously, that's a maximum. All right, but now we have these other scenarios. So if our first derivative is positive and the second derivative is 0, then we're in a scenario where we're neither concave up or concave down, so that's a point of inflection. And actually, I'm going to come back here and say this can be any value. The second derivative is 0 is a point of inflection. If this is 0, if the first derivative is 0, that's a stationary point of inflection. That happens in something like x cubed, where we've gone from concave down to concave up, but for just a moment in time, our graph is flat. So this is if the first derivative is 0. If the first derivative is not 0, that's something like this scenario, where I've gone from concave up to concave down, but I have a second derivative of 0 for my point of inflection. I don't always have to start concave up, as we've seen. X cubed starts concave down. So to know what that is, I would need to make a sign chart for my second derivative to know that my second derivative went from negative to positive or positive to negative. All right, so I'm going to stop there. Make sure that you toolkit this stuff. Go look at the answer document for this whole thing. And if you have questions, come see me or Miss Patali.